So that's the basic idea of SNMP. So you might not handle SNMP if you are an ordinary user. However, you would need to do that if you are a vendor. If you are in a vendor, and the vendor product usually need to support SNMP agent running on their product. And then one quick solution is to install net SNMP on the product. That would the net SNMP will handle will do will count the statistic to support MIB. So it will maintain MIB values, the entire database, the entire object-oriented database. Internally, externally, you would take SNMP query either to read or set the MIB values. So this is how SNMP agent works. The next application is voice over IP. Here we look at two protocols. Actually, right now we only use either SIP. Mostly we use SIP. And there are some proprietary applications that do not follow SIP. And H.323 has been a very old protocol, and it's quite obsolete. So much fewer products support H.323 now. SNMP has been replacing H.323. And we will look at the open source implementation, which is OpenPhone. Oh, sorry, the slide needs to be changed here. It's we will look at the open source project called Asterisk instead of OpenPhone. Asterisk is open source PBX, private branch exchange. Private branch exchange. It's more like a local exchange, VoIP exchange. Okay, and voice over IP compared to the circuit switched phone call, it is that it's a voice call over IP packets. So, and it's hard real time. Compared to streaming, it's hard real time because it's bidirectional real time traffic. And compared with the plain old telephone system, it's inexpensive, simplicity, and less bandwidth consumed, and more possibility to extend. So here's the possible architecture if H.323 is adopted. What you have is you have a voice over IP network where you would have H.323 terminal, which is a phone, usually the phone, and the phone could be a software phone or hardware phone, or a software phone, then it will be a software running on a computer, or it could be a real hardware phone supporting H.323. And then there will be a router that will get you to the internet. However, there will be two other devices. One is a H.323 gateway, gatekeeper. The gatekeeper will be handling the control plane. Okay, so you send when you want to set up a call, you send a control message to the gatekeeper first, The gatekeeper is supposed to find your partners on the network. Okay, so it handles the control plane. The MCU multi-point control unit. It's to handle the multi-party calls. If a call involves more than 2 parties, then you need a multi-point control unit so that you could have multi-party calls. Okay, so MCU also handle the control plane issue and also the data plane issue of if it's a multi-call. If it's a multi-call, then it handle the control plane issue and also the data plane issue, while the gatekeeper only handle the control plane. Okay, and then the internet. Okay, but if you are calling someone on the traditional phone, then you need to go through another gateway to get into the traditional phone network, because the call E, if the caller is here and the call E is here, then your call needs to traverse through the IP network and also the telephone network. However, if the caller and call E are both on the internet, then you don't. Then probably there's another, the call E is connected to this IP network. Perhaps another gateway, another gatekeeper on its site. The major reason that H.323 has been replaced by SIP is because of its complexity, especially in the control plane protocols. It was designed by simply said, the H.323 was designed by telecom people, while the SIP is designed by the datacom people. And the way telecom people does things, they want different protocol to handle different things, especially in the control plane. So it has it has the control protocol of Q.931 and H.245. So here's a list. The RAS that will handle the registration, admission issues and status issues. The H.245 will handle is a control protocol for capability negotiation and channel setup, while Q.931 handles the call setup and tear down between 2 terminals, and T.120 handles the conferencing, multimedia conferencing, and RTP/RTCP would handle the real-time traffic synchronization and transport. So given these protocols, how do they work together? This is how. So at the beginning, you would need to do registration. I mean, when making a phone call, you need to do a registration and admission. That's done by RAS protocol, and then call set up by H.931, and then terminal capability negotiation and channel setup by H.245, and then the call has been up, so you can send the RTP message and RTCP message. RTP message to encapture the voice data, while the RTCP is for quality report, the path quality report. So most of the time you stay here, and then after the call, so when the call is going to end, it would need to close the channel first by H.245, and then tear down the code by Q.931, and then disengage by RAS. And so they try to give a specific mission for each control protocol. However, this is of course too complicated. So that's create a space for SIP to simplify the whole thing. So SIP is to replace H.323, and it also support the multimedia session, not just a phone call, but could be more than a phone call. And it's a text-based protocol with a message syntax similar to HTTP. The syntax is similar to HTTP, and it's a client-server scheme. So, so you also have they call it the UAC, the user agent client, which will be a phone, either a hardware phone or software phone, and then connected to a local proxy server. And there could be other redirection server or location server to help the client to locate the CoE. So if you are a caller, you need to identify the CoE. Then you need to query the location server or redirect server. So the protocol message is much simpler, that you have SIP as the only control plane. I mean, for signaling, for call setup. And it would it has SDPs and SAP and SDP session description protocol and session as a SAP and SDP as the supplementary protocol to SIP to describe the session. Okay, and then that's the control plane. The data plane would have the multimedia traffic running on top of RIP, UDP, and IP, and with RTCP for path quality reporting. Okay, so but then you would ask why we could simplify. These are the protocol possible request and response of SIP. So you would ask why we would have much more complicated protocols in H.323, but now much simplified in SIP. Where do the complexity go? Where do the complexity go? In H.323, using those many control protocols, they try to do negotiation and add core features, and those additional information has been shifted to the options in SIP. So here, the SIP has a message called options, and the option here are for features supported for a call. So I put all the complexity add-on of a call or feature of a call into the options. So if I have some feature of the call, for example, this is a three-way call, then I need to use options, and I describe in the options. or if this is the high quality code, the quality needs to be high, so the encoder needs to be aware of the demand, and that should be described in the options. However, in H.323, they explicitly put those features in the protocols messages. So in H.2.3, they put the complexity to the protocol itself to create many protocols for different things. However, in SIP, they hide the complexity into options, because not every user would need that features, would need those core features. Most user would just have a simple plain code. They would not need core features. But when they do, they would just they could use options, SIP options messages. So that's the advantage. With H.323, you need to specify all those features and options, even though you don't need it. Then you still need to go through those protocol messages. But now in SIP, you don't. If you are making just a plain code with no features, then you don't need to specify them. But if you do, then you specify with with options. So if you look at the SIP RFC, the IETF RFCs defining SIP, you will see a lot of document describing the options, the possible options that could be supported by SIP. Those are documented in a lot of documents, that create a lot of documents to describe the core features. Okay. So here you see invite, ACK, buy. These are probably the mostly used, and also register. Okay, you are a client. You need to register through the location server, so that you can so that the client server can find each other, so that the coder and COE can find each other. So you need to use register to identify yourself, to register yourself to the location server. And then you invite. If you want to make a phone call, you send invite message. To the location server, and location server would either redirect or forward your invite message. And then you got the ACK back from the COE. That would when you got an ACK from the COE, if you are a caller, you got an ACK from the COE. It means that the call has been set up, and it's a confirmation of the response from the COE. And when you are about to terminate the call, you send the buy protocol message. Okay. And when you send the request, that you usually will get the response from the other peer. And again, with the 200 something as successful, and 300 something usually means something has happened, but it doesn't imply failure. But for 400, 500, 600 something, these all imply failures. So here's an example where the UAC, which is a caller, invite UAS. What is UAS? Is there a figure? Okay, COE. Well, the COE, you send invite, and with the SIP URL. And then if the destination IP address is known, meaning the location server knows where it is, where the call E is, then it will send it to the call E directly. If it's unknown, then it's redirected to a local proxy server with a location server on it, so that the location server will be able to identify you. Or you could be redirected in the redirection mode. The redirection server will send back the call E's new location. So either redirect or proxied, meaning the client, the call E, has been notified the new address of the call E, or not notified but directly forwarded by the proxy. Okay, and then the call E would answer with 200 something to act the invite messages. Okay, and then the session is established. The caller and call E can send RTP and RTCP to carry their real-time, bidirectional real-time voice data. Okay, so we have compared H.323 and SIP. The difference is there are too many control protocols in H.323, and they have protocol for different things, and most of them are describing the core features, the capability of the peer. However, in SIP, they put all these into the options. So if a call is a plain call that has no features to support, then you don't need to send the options message. And there's some other difference in the way they encode the message and capability exchange. In SIP, is done only by options. However, it's described. You need to go through it explicitly in H.323. And the supported data types are different, and the capability of handling a conference is different too. Both could handle multi-party calls. Okay. But H.323 try to handle it in a better capability. Okay, the open source implementation 6.6, that's asterisk. It's asterisk is integrated PBX, which is private branch exchange system. That is if an enterprise has client, many caller and call E inside, and however, I only have one interface to the network. Then I need a PBX so that the client inside the company, the enterprise, would have extension number. So they have extension number to be reached, and the PBX need to hide the complexity inside. It's like at NCTU we have a number which is a 037 5 571 2121 571 2121. That's the representative number we have for NCTU. But inside there are many extension numbers. So you have 56601. That's the extension number for the computer science department. So, and similarly for VoIP clients, they also have extension number. They could also have extension number that hide behind the external wall. So that's the purpose of PBX here. And the only difference is that this PBX can handle voice over IP, not just a traditional phone. And it provides the flexibility to build your customized VoIP system. It could add or remove module. So this is a part of the asterisk which handle the outgoing extension, meaning how the PBX works. If there are caller inside the enterprise trying to call out. Okay. And I think I'll skip this. Basically it's a threaded implementation where each thread handle for each call, handle each caller. So thread per call, one thread per call.